Today's topic is fractional indices, and there is basically one law which I have separated into two examples. So if you have a to the power of 1 over n, or 1/nth, then this is the fractional index, okay? Then the law is that you take the base to its numerator, okay? The numerator goes along with the base, and you take the root of the denominator. So remember, I remember this in the sequence of D comes before N in the alphabet. Okay, or when you have A to the power of M over N, then again the numerator goes along with the base. Okay, numerator goes along with the base, and the denominator goes along with the root. So a fractional index can be solved by taking the root, the denominator's root, and the base to the numerator. Right, if we look at this example, 8 to the power of 2/3, then the following will happen. 8 to the power of 2 goes into the third root, the cube root, okay? And you can put this into your calculator. Most calculators will actually solve this. So you have shift, then take the third root of 8 to the power of 2 and press your equal sign, and it gives you an answer of 4. You can, however, in simple examples like this one, also solve 8 to the power of 2/3 with your calculator. So you would then just simply press 8 to the power of, use the key where you can express any power, okay, and then press 2/3, and if you press equals, your answer will also give you 4. Okay, in another example, we now have a fraction and the denominator is the root. So remember now, the 27 goes to the power of 1, and then you divide that by 3. That's basically how you then change the cube root to a fractional index, okay? So you can change the root to a fractional index, or you can change the fractional index to a root. Those are equal. And again, you can press that into your calculator, pressing 1, fraction sign, 27 to the power of the key. That gives you the ability to press any power or index, and then make that a 1/3 root. And in this case, if you press that, it will give you an answer of 1/3. Okay, now a very good habit, which I did not now apply in these examples, is to always take your base, right? Always take your base and write that in its prime factors. Okay, because that makes solving in many cases much easier. So if you have a numerical base, then write the number in its prime factors, okay? And that helps a lot with solving a bit more complicated problem. All right, if we look at the next example, you now see it's the square root of a whole complicated fraction, which is to the power of 5. So remember, we will always apply BODMAS, which means we must first solve the bracket, okay, to the power of. So this is a power to a power. 4 has a power of 1, which we multiply by 5. I taught you in a previous video how to actually move the power to a power, and if you have not seen this, please look at the basic laws of indices. The video shows a nice personal movement in how to remember this. Okay, so this becomes 4 to the power of 1 times 5, which is 5, and a to the power of 4 times 5, which is a to the power of 20, right? Then the denominator is 9b to the power of 6 to the power of 5. So that's 9 to the power of 1 times 5 is 9 to the power of 5. And then b to the power of 6 times 5, which is b to the power of 30. Okay. Now in most cases again, you can just simply place 4 to the power of 5 and 9 to the power of 5, which will then give you an answer. Okay. Before you do that, you must first solve the square root. Now remember, solving the square root, this is the 2. You just simply divide the index by 2. The root becomes the denominator. So this will look the following. 4 to the power of 5, and then divide that by 2. And a to the power of 20, and divide that by 2. Over 9 to the power of 5, divide that by 2, and a to the power of 30, divide that by 2. So you could now go and you could express the 4 in its prime factors, which is 2 to the power of 2. Okay, so can we just show you? 4 to the power of 5 halves would become 2 to the power of 2 to the power of 5 halves, okay, which you would then multiply because it's a power to a power. We could cancel the 2's, which then gives you an answer of 2 to the power of 5, if you would have to do it without a calculator. In most cases, you would just simply place 4 to the power of 5 over 2. Maybe I should just show that once again. So, use your calculator, press 4, then use the power key, which enables you to do any index, to the power of 5, make it a fraction over 2, and that gives you an answer of 32. Okay, so that would be 32, and then a to the power of 20 divided by 2 is a to the power of 10. And if you press 9 to the power of 5 halves into your calculator, it will give you the answer of 243, and b to the power of 30 divided by 2 would be b to the power of 15. Alright, that is quite simple and easy. I want to show you just another example, and if you look at that, we have all the bases a 3. If that was not the case, you would actually rewrite your numbers into prime factors, because remember, we can apply the indices laws only to the same base. So in this case, we have a power to a power, which means we need to multiply the index, which gives me, cancel the 2 with the denominator, 3 to the power of 3 times 3 to the power of negative 1 half, divide by 3 to the power of 1 half. Okay, now we got all the bases 3. Now remember, when we multiply powers with the same base, we will add the index, right? And this is divide. When we divide powers with the same base, we will subtract the index. Right, and then if you calculate 3 plus negative 1 half minus 1 half, you will in fact get 3 to the power of 3, and 3 to the power of 2, 3 minus a half is 2 and a half, minus another half is 2. 3 to the power of 2, and that in fact is 9. So these are the fractional indices. Applying the law, I repeat, you will just simply make the numerator the index of the base, and the denominator becomes the root. If you do it the other way around, for instance, if you have a to the power of n and you want to solve the nth root, then the n just simply becomes the denominator, so you simply divide by n, which then removes the root. Okay, that is the fractional index law.